All right. Today we're going to start concept 17, and we'll finish it today. It's a very quick concept, okay? And it's another way to graph, which helps a lot. Most people don't realize this. We're going to use this method. Listen, guys. We're going to use this method when we graph any other function from this point on. So you know how you learned slope and intercept? Today we're going to learn just called intercept method, which is finding the x-intercept, finding the y-intercept, and then just connecting those lines. And many of you have done this already in Algebra 1 and realize that this is a lot easier than using slope-intercept. But it is important to know what a slope is, because when you move on to calculus, you're going to talk about slopes as rates of change and these things called derivatives, which are extremely important in calculus. You can't learn any calculus without it. So the reason you're learning slope-intercept is not just to graph lines, because you know what? If you just were graphing, this method that we're going to learn today is a lot easier. But knowing the slope-intercept, like you did on your quiz today, and we talked about last two classes, is important. You're going to use it again and again. Again, though, this is another way of graphing that might be a little bit easier for you. Okay, so we're on concept 17. We're talking about intercept method. Okay, we're talking about intercept method. First, what does an intercept mean? I'm hearing mumbling, but not seeing hands. Trevon.
Crossing the two lines.
Okay, good. When something crosses another line, that's the intercept. So in this case, when we're looking at intercepts, which intercepts are we looking at? The x and the y. Very good. Again, the intercept is where it's going to cross the axis. In the case of this, we're looking at an x-y axis. So all it crosses the x-axis or the y-axis. Now, we've already actually done half of this because you guys already saw how to find the y-intercept. So let's take a look at a graph now. If I have an intercept here and an intercept, let's say, all the way out here. Somebody tell me the coordinates for those two intercepts. Jared.
Whatever, first one. Oh, well, yeah, all right. The one on the y, axis. That would be, x would be 0, and y would be 3.
Okay, good. Other one?
The other one would be, x would be 5. And the other one would be, y would be 3.
Good. Is that clear to everybody? We're just listing points right now. Very basic. Okay, 7th, 8th grade math, you should know this from. Now, if we think about this, look at the coordinate, for example, on the x-axis. It's 5, 0. If the intercept was not there, let's say the intercept was right here, what would that coordinate be? 2, 0. What are you noticing about the y-coordinate? They're both what? 0. It's not a trick question, guys. Look at the y-coordinate in both of these intercepts here. The y-coordinate are both 0. Now, look at the x-coordinate for the y-intercept. What is it? It is also 0. So, we can think logically. If you're finding an x-intercept, the y-coordinate will be 0. If you're finding the y-intercept, the x-coordinate will be 0. So, if you're finding an intercept, set the other coordinate equal to 0. Okay? So today's lesson, that's all you're going to have to do today. So to find an intercept, set the other, and I'm going to say the other for now, coordinate equal to 0. Whenever you're trying to find an intercept, set the opposing coordinate equal to 0. Again, this works in both directions. So if you're trying to find the y-intercept, set x equal to 0. If you're trying to find the x-intercept, set y equal to 0.
Did you say you did some changes in notes this year?
They're on that line. So if you look, yeah, you'll see from the ones from last year.
Yeah.
Yep. You'll see the small changes. Okay, let's go through an example now. If we have an equation that says 3x equals 2y plus 7. Now, we talked about putting this into slope-intercept form, solving for y, find the slope, find the y-intercept, then graph it. you can do that, and that's fine. But it's a lot easier just to find the intercepts and graph them. So, if I want to find, let's say the first thing I want to do is find the x-intercept. Okay, let's say I want to find the x-intercept. What can I do here based on the statement we just made? Vanessa? Say again? Easier than that. You could do that and then eventually solve easier. Brandon? Set y to 0. Remember we said if you're trying to find an intercept, set the other coordinate equal to 0? So here, when you're finding the x-intercept, in your notes say set y equal to 0. So literally put a 0 in for y. We got 3x equals 2 times 0 plus 7. Again, if you're finding the x-intercept, just set y equal to 0. So here we're left with 3x equals 7, or x equals 7 over 3. Well, again, when we look at points, we kind of want to know the decimal, right? We talked about this. If it's a slope, leave it as a fraction. Okay, so here we're going to get 2.3 repeating. So that tells me that the x-intercept is 2 1/3. The x-intercept is 2 1/3. So if I were to write a point that describes the x-intercept, what would the coordinate itself look like? Because it's not just 2.3 repeating. I want an actual coordinate for the x-intercept. Okay, but that's still just one value. I want an actual coordinate. 2.3 repeating, comma 0. Again, this is the x-intercept. And what did we do a minute ago? Didn't we set y equal to 0? So that tells me that's the actual coordinate for the x-intercept right here. Can I do what, John? No, John, just go back and look at the notes. If you want the x-intercept, the y value is 0. So when you list the coordinate, put a 0 in for the y value. Just like we did in the equation. 3 lines above the coordinate, you see that you have 3x equals 2 times 0 plus 7. You've set y equal to 0. So take this 0 value right here that you've set y equal to and put it into the coordinate. Okay, so you're going to have a coordinate for the x-intercept. And what about for the y-intercept, guys? What am I going to do? Set x to 0 and do the same process. Okay, so over here, let's find the y-intercept, and we'll say set x equal to 0. Jason, whatever you're doing, knock it off. So we have 3 times 0 equals 2y plus 7. Okay, 3 times 0 equals 2y plus 7. Now here you're going to have 0 equals something, and that's fine. There's no problem with that. So we have 0 equals 2y plus 7. At this point, what can I do? Good, I can subtract 7, or I can actually subtract 2y. It doesn't matter. Traditionally, though, we subtract the constant, so I would move the 7 over. But you could move the 2x over, you'll get the same answer. So I'll get negative 7 over here equals 2y. Again, I'm subtracting 7 from both sides. When I subtract 7 from 0, 0 minus 7 is negative 7. At this point, divide by 2. We're going to get negative 3.5 equals y. Again, 7 divided by 2 is 3.5, negative 3.5. Now I need to list the coordinate. What should the coordinate, Derek, look like?
0,
Very good. Okay, 0, comma, negative 3.5. Is it simple enough, guys? It's a very easy method, and it works a lot better than having to put in slope-intercept. It is important to know slope-intercept because the slope has a meaning, like we talked about in the actual quiz. And that was part of the quiz to see what the meaning of the slope actually was. Now, once I have 2 points, if I want to graph this line, we have my 2 points listed. How do I graph the line? Just put them on the x and y axis and do what with them? Just connect them, because again, you only need 2 points to make a line. So if you can find each intercept, that's 2 points. Once you have 2 points, connect them, your line's done. And what you'll notice is that if you put it in slope by intercept form, the exact same line appears. There's no difference whatsoever. The exact same line appears on the graph. So for this one, you know what? Let's use GeoGebra for this one so we can see the exact value. So we're going to have 2.3 repeating and negative 3.5. So we're going to graph our x-intercept, we're going to graph our y-intercept, and then what I'm going to do is I'm going to use the program to show us what the slope form will look like. And it's going to be the exact same answer here. So here, we have our first point. Our x-intercept was negative 2.33333, which I can write as a fraction. So I'm going to write it as negative 7/3, comma, 0. That's my first point. There's my x-intercept. It just appeared as A. I want to graph the y-intercept. It's 0, comma, negative 3.5. There's the y-intercept down below. So right now I've got, let's zoom in a little bit, see if this works. No. There we go. It was or was not negative? Thank you, sir. Okay, so at this point we've got our y-intercept, our x-intercept. All I need to do is connect them with a line. So in this program there's a function that puts a line through 2 points. All I have to do is select the 2 points, and it puts a line right through it. Now, take a look at the line right here. That doesn't look like it's in a form that we would ever use here, right? So what can I do is this. I can take a look at this one, and I can right-click and put it into y equals mx plus b form. And we'll see that we clearly have a slope and a y-intercept. And look at the y-intercept. See negative 3.5? What was your y-intercept? Negative 3.5. Same thing. It's amazing, isn't it? So the 1.5 is your slope. What is 1.5 as a fraction? Who can tell me?
I don't know how to change it back. I forgot it.
What is it? 3/2. Or, yes, 1.5, obviously. But as a fraction, it's 3/2. So let's watch what happens here, guys. Take this value, go up 1, 2, 3, go over 1, 2. There's another point right there. Okay? I don't want to point out that. So again, if I go up 1, 2, 3 values, go over 2, I end up at point C. So my slope here is still 3/2. So I still have a slope, I still have a y-intercept, but we did not use that technique in order to graph this. So this is just another way to show you how you can graph certain things. Are we okay with it so far? Yes. Let's go through that right now. All right, so pull out your calculators if you have a graphing one. If not, look on with somebody else, please. So if we wanted to graph this line that we just looked at a second ago,
They taught us this in 8th grade. Some of us in 7th grade.
okay. So this is what your calculator looks like. Now if you have 83 and 84, it makes no difference, same exact function. Even 89 is pretty much the same. Okay? Now, at this point, you want to graph something. Focus, Jason. You want to graph something. There's one button on here that has a graphing command. Where is it? Y equals. Very good. So again, this is how you input the graph. This is how you show the graph. So if I hit graph right now, nothing's going to show up because there's nothing in my y equals. Okay? There's nothing in my y equals. So I want to go back to my y equals. At this point, just plug in the function. The last function was 1.5x minus 3.5. So I type in 1.5x minus 3.5. And again, this is a negative sign down here. This is not a minus sign. If you had a slope that was negative, you use the negative sign down here. But since we're subtracting 3.5, use the subtraction sign. At this point, simply hit graph. And what you're going to see is the exact same line appears that we just had. The y-intercept is negative 3.5. It has a slope of 1.5, or 3/2. Now, let's say hypothetically your slope was given as a fraction and not as a decimal. So we didn't have this decimal value right here. Go back to your y equals. If you're going to put a fractional slope, you have to put it in parentheses. It cannot go by itself, because if I wrote this, if I wrote 3/2x, what the calculator is doing is it's saying 3 divided by 2x. It's literally saying this. It is literally saying 3 divided by 2x, which is not what we want. We want 3 divided by 2x. So you must put parentheses around your 3 halves here. Okay, you have to put parentheses around the 3/2. Yes. Okay, hit zoom 6. Hit zoom 6, Derek. Hit once you put in the calculator, type zoom, press zoom and then 6.
Oh yeah.
I'll show you that one in a second because you're probably not in the right graphing window. Did that fix it? So, if I were to graph the exact same line with my fractional slope, you have got to put it in parentheses. Now, here's what I want to show you, and this is a good point that Derek just made. What if, you know how we always talk about negative 10 to 10 and negative 10 to 10 for my x and y axis here? This ranges from negative 10 to 10, this ranges from negative 10 to 10. What if for some reason my window was not set up that way? So this is giving me the window commands. It's saying that the minimum x is negative 10, the maximum x is 10, going by ones. The minimum y is negative 10, the maximum y is 10, going by ones. So let's say somebody had used your calculator and it was at negative 25 to negative 10. Okay, and I try to graph this. What I'm going to see is I'm only going to see part of the quadrant here. Take a look at the graph. It doesn't even show up because my graph is really over here. So it's off the screen right now. So if your settings are different because you used it for another graph, all you have to do to go back to the standard is press zoom and then see zoom standard number 6. Hit 6 and then it always goes back to the 20 by 20 graph or the negative 10 to negative 10 graph. So if your calculator is ever zoomed somewhere else or you're looking at a different portion of the graph, just press zoom 6 and it'll go back.
Hey, wait. Mine's going the opposite way.
Again, zoom 6. You probably didn't have the right symbol, John. Now, if I wanted to graph something only in the first quadrant, who can tell me what I should change my values to here? I only want the first quadrant. Derek? Close. First quadrant, not second quadrant, Derek. You give me the second quadrant. I want the first quadrant, Daniel. Good. X minimum has to be 0. What about the Y minimum, Daniel? You said negative 10 to 0. This is 0 to 10. Sorry, if you said change the negative 10 to 0, I apologize, Derek. I thought you said negative 10 to 0. You meant change it, but I interpreted that as negative 10 to 0. So here, we're going from 0 to 10 and 0 to 10. Now, take a look at the graph already that's showing up down here. You're going to see that this is the graph of the first quadrant. So where's the rest of the quadrants? Where are they? They're off the graph. So here's what we really have right here. This is the first quadrant, second, third, and fourth quadrant. So if you want to only graph the first quadrant, go from 0 to 10 and 0 to 10. If you want to graph the second quadrant, go from negative 10 to 0, and then from 0 to 10 for the y. So let's go through this one. I want to graph the second quadrant now. So for my window, in the second quadrant over here, I know I'm going to go for the x value, negative 10 to 0, and then in the y value, I'm going to leave it as 0 to 10. And let's see what that one looks like. Well, here's the second quadrant. I don't see anything though, because again, where is my graph located? It's located here. So I'm not seeing anything on the graph right now. Okay, because really the line is over here. It's cut off my graph. So this one wouldn't help me at all, right? I wouldn't graph the second quadrant in an example like this. Maybe the third quadrant will help me. Let's take a look at that one. If I want to graph the third quadrant, in the third quadrant down here, I know I'm going from negative 10 on the x to 0 and negative 10 on the y to 0, because this is my third quadrant right here. So I have the x set up already. For the y, negative 10, enter, 0, enter. Graph that one and take a look. Here is the third quadrant, and we'll see the graph. Because again, this is what it really looks like. This line really continues on. So now we are looking at the graph of the third quadrant. In the fourth quadrant, okay, we can do 0 to negative 10 for the y to get the bottom part, and 0 to 10 for the x to get the right part. So we'll get the fourth quadrant there. It's important to know how to use these tools, guys. The calculator you're holding right now has so many tools on it that most people don't even know about. Okay? There's one major thing that we're going to look at in a second where you're going to need a graphing calculator to do this. In addition to doing your homework, you're going to need a graphing calculator to do it. Okay, let's look at one more example, okay? Before we do that though, let's define a term that we're going to use. What the heck? No.
Oh my gosh.
Okay. We already said this, just to reiterate. So, define the y-intercept, set x to 0, define the x-intercept, set y to 0. We already said that. Now, it is important to understand the next thing I'm going to tell you because it's used over and over again. The x-intercept has a specific name for it. It is not really called the the y-intercept is always called the y-intercept, but there are other words to describe the x-intercept. Okay? 3 words. The first word to describe the x-intercept is called the root of the function. I will rarely use the word x-intercept from this point on, just so you know. The root of the function. That's the first term. Okay, and think about roots. Roots are things that are in the ground, right? So the way I remember the word root is, it's where it's like touching the ground level. Think of the x-axis as the ground, right? When does it go into the ground? When it crosses the x-intercept? So it goes underground, those are like your roots. So when I think of root, I'm thinking in my mind, when I have a line, this is where it crosses the ground, and these are the roots down below here, okay? So whenever I think of that, I think of the root. Next is called the zero of the function. The zero of the function. And zero of the function is easy to remember because you set y equal to 0. Again, this is only for the x-intercept, not the y-intercept. This is only for the x-intercept. Let me even do this so you can see. It's also called the zero of the function. And the zero of the function is a command on your calculator, actually. And I'm going to show you in a minute how to use that. Finally, if you don't have a function, if you just have an equation, we also call it the solution to the equation. And I'll explain that one in a sec. Solution to the equation. So it's the root of the function, or the zero of the function, or the solution to the equation. Any of those 3 terms. Okay? Any of them will work. Again, the root of the function, the zero of the function, and the solution to the equation. Let's look at a few examples now. Trayvon, is that a question or is that you stretching? Shoot. That's what I'm going to do right now. Okay, let's go over solution to the equation. So, if I had something that said,
What was the third one?
solution to the equation. If you had okay. If you had this equation here, what would you do to solve it? How would you solve this one, people? Derek? Backwards FOIL, good. Or just factor. Factor. Backwards FOIL or unfoil, same thing. So let's back to this. Good, 1 and 4. I made this one easy on purpose. X plus 1, X plus 4. So, what we are doing here is the following, guys. We are actually finding the x-intercepts. So we're finding the solution to the equation. This. It's your last warning, Jason. Come on, focus, man. This is the equation. The answers we get are the solutions. Yeah, you got 20 minutes to sit there quietly now. Yep. We make a T-chart, and we have our 2 solutions here. Okay, we have our 2 solutions here. These are the same things as the x-intercepts. They're the same thing as the roots. They're the same thing as the zeros of the function. And let's discuss why now. And we're going to talk a lot more about this when we get to quadratics. But just as an easy example, if you were to graph this quadratic, I can tell you immediately what it will look like. because of the roots, because of the solutions, because of the zeros, because of the x-intercepts here. These are x-intercepts because traditionally, doesn't a quadratic or an equation look normally like this? Right? It says y equals that whole equation usually, or f of x equals. If I want to find the x-intercept, we said set y equal to 0. Well, isn't that actually what we did right here? We set the y value equal to 0. So if you're given a function like this, and you set y equal to 0, and then you find the solutions to that equation, you're finding the x-intercepts. So this graph will have an intercept here and an intercept here. Those are two of the intercepts already. And beyond that, it will just look like a parabola. So we're going to have some sort of a parabola looking like that. So again, when you're solving for the solution, you're actually finding the roots of the equation. You're finding the roots of the equation here. Let's look at another example.
You shut up, Miguel.
If we have
I'm saving that seed for the weekend. Let's do it a weekend.
If we have this equation here, now you learned in Algebra 1 what a quadratic was. You may not have graphed it before, and we're not going to do that again until concept 20. But for now, we can already find the x-intercepts. If I want the x-intercepts, I set what to 0? Y to 0. So I start by doing this, which is in our form that we can solve now. Again, because there's a 0 on one side of the quadratic, we can then factor or unfoil, as Derek said. So we say 0 equals. Okay? What is it? Very good, Vanessa. -4 and 3. Okay, -4 and 3. So when I solve these, I take the opposite values, right? So this tells me that I have two x-intercepts. I have two x-intercepts. The reason I have two x-intercepts is because it was x squared. We'll talk about that one more also. But here I have two. So if I want to graph this one, I know already I'm going to have a point at 4 and at -3. And what I'm going to see is the graph will look like this time. Again, I have two x-intercepts, or I have two solutions to the equation, or I have two roots of the function, or two zeros of the function. Any of those terms are all interchangeable. Again, two zeros, or two roots, or two x-intercepts, or two solutions to this equation.
So it can't go
It can, and we'll talk more about that with quadratics, but that's when there's a negative here, Derek. Remember we said if there's a negative in the front, the things reflect? We talked about that with concept 15. Okay, so again, if you want to find the x or y intercepts, you set the other coordinate equal to 0. Now let's look at some examples that are a little more tricky. And here's where you're going to have to use your calculator for. So, for the next example, let's say we have g of x equals g of x equals, listen guys, 2.7x minus 6. Find the roots of this function. The goal here is to find the roots of the function. Okay, find the roots of that function. So the roots being what again? X-intercepts. X-intercepts. So what do I set equal to 0 here?
Y.
Well, there's no y. Good. G of x. Remember, that's our y value always. So start by saying this. Now with this one, it's not that tricky because I can move the 6 over and divide by 2.7. So add 6 to both sides. I'm going to have 6 equals 2.7x divide by 2.7 divide by 2.7. Now, using your calculator, figure out what 6 divided by 2.7 is. It should be a little more than 2. Okay, because 6 divided by 3 would be 2, right? So 2 point, what is it? 2 point? Okay, that tells me that my x-intercept, or my root, or my 0 of the function is 2.2 repeating. Now, if for some reason I was not able to solve this equation, which we'll see in the next one, there's another way to do this, and I want to show you that. So everybody open your calculator up and go to your y equals. Okay, go to your y equals, clear out whatever's in there, and write in the equation. So 2.7x minus 6. Okay, 2.7x minus 6. If you change your window settings, make sure you hit zoom 6. Okay? Now, at this point, we said a minute ago that the x-intercept was 2.2 repeating. Well, that makes sense. Take a look here. It's right after the number 2, isn't it? Here's 1, here's 2, here's 3. It's right in between there. So our answer was most likely right. But let's verify it. Here's how we do it. Do what I do here. Press second, then press, see, calculate. It's above the trace. So you're going to press second and then hit trace. It'll bring up this calculate function. Everybody there? Okay, again, second and then hit trace. What are we finding? We're finding the root, aren't we? We call the root also the 0 of the function. Where do you see 0?
Number 2.
Number 2. Go down to number 2, hit enter. Okay, it will say left bound. Tell me what the left bound is. And here's what this means now. The calculator is asking you to give a range that it's going to search in. So, I want to search in this range somewhere. Right? Isn't the root somewhere in between there? It's right here actually. So where am I searching? I'm searching between like right here, and I'm searching between here. So I need to give some values. If I were to give a left bound, what is some value of x to the left of 2.2 here? 1. Okay. So in this case, let me choose the value of 1. So for left bound, type 1 and then hit enter. Okay, again, I'm choosing 1 as my left bound. I'm choosing right here as my left bound. Now I want to choose something on the other side. So maybe, what, 3 or 4 over here?
3.
Okay, 3 works, that's fine. So 3, enter. Oops, let's go back, hold on.
Wait.
It might be right around, yeah.
Okay, left bound is 1, right bound is 3. Okay, you're all at this point. So again, left bound was 1, enter. That was this value right here. Right bound is 3, enter. So now take a look at these little arrows up here. They're saying search between those arrows. So these 2 arrows that appear on your screen, it's searching between there. And then it says enter a guess. You don't actually have to give a guess ever. Okay? You don't have to give a guess as long as your bounds are correct. If you give the wrong bounds, then your guess might take effect. But you can just hit enter right now and take a look at the root. What does it say? 2.2222222, which is 2.2 repeating.
I have some help for this.
Okay? I'll go through it one more time. Again, second, calculate. Go down to the 0 function, hit enter, or just hit 2. It'll bring up the 0 function. We want to guess a number to the left of the root. So watch, this time, I'm going to guess the number -5. It doesn't, oops, -5. It doesn't actually matter, because -5 is still to the left of my answer. And I'm going to guess the number 8, because that's to the right of my answer. And then I'm going to hit enter again. And still, what is my answer? 2.2 repeating. Now, you can't guess an x value if it's off the graph, though. So if you try to guess, like, if you choose a left bound as -20 and a right bound as 15, it's going to give you an error. You have to guess one of the x values that's on the screen. So again, what are you doing? You are building a wall around the root that it can then search within. Again, just this last one, we did -5 to +8. So we put a wall around that root, and the calculator is searching in that wall to find the root. And it's using a method that's called Newton-Raphson method. Isaac Newton invented it a long time ago, and it uses calculus. And we're actually learning that right now in the calculus class. 12th graders are learning how a calculator itself can actually find the root. And it's a very interesting method. It continues to guess over and over again until it hones in on an answer. And then it actually is able to find the exact value. But it does it so fast that you don't actually see it happening. But it's the same thing. It continues to guess what that root is over and over again. If we have time in the end, I'll show you how it does it. Okay, let's look at an example. So everybody, we were we were able to solve this by hand and then on the calculator. Let's look at another example right now where we cannot solve it by hand. Again, let's look at an example right now. So let's open a new problem where we cannot solve by hand. So here's the equation. Now, we can try AC method for this one. Okay, AC method will not work here. They're not integer values. We can also use the quadratic formula. That would give us the exact answer. So I'm sorry, we could do this by hand with the quadratic formula. But you know what? Once you learn how to do this other method, there's no use doing the quadratic formula. So if I want to solve this one, I want to find the roots. I put a 0 here. Okay? Again, at this point though, I stop. There's no more work that you need to do. Go straight to your calculator. You don't need to use the quadratic formula right now. Okay? You don't need to use it right now. You will need to use it later on. I'm telling you now, it's good to know the formula, but you don't need to use it in this case. We can find the roots on the calculator. Let's jump right over to the calculator now. So open it up, go to y equals, clear out whatever you've got there. We're going to write the function. We've got 3x. Everybody know where the squared key is? Right here, right? Now, if you didn't know that was there, you press caret 2. That's the same thing as squared. So if you want to cube something, press caret 3. It just squares it or cubes it. It means raise it to the second power, or raise it to the third power, whatever you may be doing. So 3x squared plus 5x minus 5. That's my equation right there. I'm going to hit graph. Now, how many x-intercepts do you guys see? 2. Again, because it's x squared. Because this function was x squared, we have 2 x-intercepts. And we'll talk more about that again with quadratics. Now, I want to find the roots. Well, which one do I want to find first? Thank you. It does not matter. But it does matter when you give the search domain. For example, if I want to search for the left root, I need to pick a left bound here and a right bound over here maybe, so that it only finds this answer. What if for my left bound I choose this, and for my right bound I choose this? How is it going to know which one to pick? It's not. It's going to give you an error. Okay? Or it might only pick one of them over and over again. You'll never get the second one. So if you have 2 roots, you have to be very specific about your search domain. So if you make the left bound -7 and the right bound 5, it doesn't know which of these roots to pick. The calculator will get confused and say there is an error, or it'll only give you one of the root every time. It won't give you the other one. So if we want to find the left root, let's choose a number like, I don't know, this is around -2 and change. Let's choose -5 and then maybe -1 right here. So -5 here and -1, so that we only get this root. So we're not looking at that root. Okay, so here, let's go through this process one more time. We press second, calculate the number 2 to bring up the 0. Now for a left bound, we said we'll choose -5. That gives me a number over here. And we'll choose -1, which is right here. And then I don't know what's in between. Okay, so I just hit enter and take a look. It picks the root that we were looking for. So the root in this case would be -2.37 if we round it. Okay, or -2.4 to round. That's one of my roots. Again, -2.4 is one of my roots. So here, one of my answers is -2.4. Let's go back to the calculator and find the other one now. Now, we do the same command over again. Second, calculate. I want the 0 function. But now, somebody give me a suggestion of what my left bound should be this time. It could be -1 again. It could be the same as the right bound from the last time. So see how this is -1 here? This is now the left side of this root. So choose the same right bound as the last time for the other one. Or 0. It doesn't matter. This time I'll choose -1 for the left bound. For the right bound, I have many options. Which one do I want to pick over here? 5. Okay, 5 works. Now, would I pick anything beyond 10? Why? Good. 10 is off the graph. You can't pick a number beyond 10, because 10 is where the graph ends. So it will give you an error. Let's try just the number 5. Hit enter, and we'll get the right bound. 0.703.
Wait, can you go over the right bound again?
For the right bound, again, quickly. Second, calculate. I want the 0 function. The left bound for this one. I'm going to pick this as my left bound and maybe pick some number over here as my right bound. Okay, so this is -1. This is 2, 3, 4. Doesn't really matter right now. So again, for the left bound, I press -1. For the right bound, I pick a number like 2, 3, or 4. Doesn't matter, as long as it's to the right. Hit enter, and you get your root. Try this stuff out, guys. Try getting the errors. Try pressing a number bigger than 10 to show yourself it doesn't work. Try searching between -5 and +8. You'll get 2 answers. It won't work. Okay, you have to try to fail before you can actually do things right. So try to make the errors on your own. See what you know, so you realize in the future, I can't actually do that. Okay? We've got one more to do.
First time we've been encouraged to make mistakes. Wait, what? And then he slides. So I would go home and play this.
Okay. Does anybody actually want to solve this equation?
I
Okay. You want to? Okay, you start solving it, we'll do it in the calculator. So, we've got 2x cubed here. Okay, we've got 2x cubed. It's no different than the last one. In the last example, everybody take a look. We had 0 on one side and everything else on the other, right? So, for the next one, do the same thing. Get 0 on one side and get everything else on the other. So on your own, move these two over here. What are you going to do to the signs? Just switch them. Again, a simple trick. If you're ever going to move something to the other side of the equation, just switch the signs. Because how do you get rid of the -2x squared? Don't you add 2x squared? How do you get rid of a positive 8x? You subtract 8x. So just move these over here and switch the signs. So on this side, take this one, put it over there and switch the sign. 2x squared. Take the 8x, switch the sign, and then repeat whatever's left on the right side. Again, take these, take the entire thing, take this entire thing, move them over, and simply switch the sign.
Oh my goodness.
Okay? Now, I've got that long equation right there. I'm going to type that into my calculator. So quickly, we're going to have
Jeez.
2x squared minus 8x plus 2x to the third minus 3. I hit graph. What I'm going to see for this one is the following. How many intercepts do I have this time? I have 3. 1, 2, 3 intercepts because it's x cubed. Find the roots of this one the same way. So if you want to find this root right here, you might pick -6, and then be careful here. This is -1, -2. So pick like -6, and then either -2 or -1. To find this root right here, pick -1, and then maybe pick +1. To find this root here, pick +1, and maybe +3. And you could find all 3 of those roots as well.
Well, how do you have to,
Same method, John. Exact same method of entering. Second, calculate the 0 function, find the left bound, find the right bound.
where's the carrot?
Okay, I'll show you in a minute. That's good.
Oh, I see
Okay. Again, tomorrow, guys, your homework tonight, I have a worksheet on your way out to take, please. Tomorrow I'll talk to you about that Newton method I was telling you.
Isaac Newton came up with this?
Newton did come up with it.
If any of my kids show up while you're just send them a story.
No problem.
You have to get the homework done.
Get out.
That guy right there.
Again, you need a calculator to do this. Jason, get out of the doorway.
What? I thought you were gonna do it.
I wasn't ready.
Yeah, so wasn't Wally.
See the story.
What do you want to get it for you?
No.
Oh, no.
I already got it.
Leave that scarf and jacket in your locker, please, when you get a chance.
I already got it. Anyway, it was a better model. So.
The one we took yesterday was Concept 16, right? The one we took yesterday was Concept 16, right?
You took yesterday? Yeah. You coming after school for 16?
Yeah.
Upstairs, Mr. Brower, library.
Alright.
You should stop recording it now.
Stop what?
Recording it.
Thanks, John. It was continuing. I didn't realize it.